In computer programming, unit testing is a testing method to determine whether the individual chunks of code works in a way it's intended to. A unit is the smallest possible testable software component. Usually it is a single cohesive function. We test the units of code so it is easy to design, record, analyze the problem to debug. The goal of unit testing is to segregate each unit of the code and determine whether it works in a way it should. Unit testing is must when it comes to larger code bases and error-prone situation to reduce problems because the importance is given to each unit. So we'll start by creating a simple class, and where I'm going to do some basic mathematical operation for the test cases. So first method is square method, which returns the square of a number, and the second method is going to be addition. It will return addition of two numbers. If the arguments given to the addition method is string, then it will return -1 instead of the addition. And we can also use raise. So now in our test file, we'll import the necessary modules, which is unit test and the function, the module that we just wrote myfunc, and a platform module which we'll be using in our test cases. And then we'll create a simple class which can be anything, but it should inherit the test class method from unit test module. And we'll create a function, and each function inside our test case is a test function. So each function should start with test, the word test before the function name. So only then our unit test module can recognize the function as a test case. So we will create an instance of the testmake object, and we'll say assert equal. So assert equal is a function which asserts an error if the expected result and the executing result is not same. So in this case we are saying we are calling the square method with the argument of 2, and we are expecting 4 as the second argument. Second argument is the expected answer. First argument is the function that is going to return the value, and the third argument is optional, which is a message, and it will be shown if the expected result is not equal to the execution result. So we can start the testing by saying unit test dot main off. So by this we can run the file and it will test our program. Here you can see we have a dot, meaning a successful test case passed, and say ran one test in 0.0 second and say OK. If there is a problem, you will get some other flag instead of dot, and you will not get OK, instead you will get failed or some other information depending on how much test cases you have. So we'll add another test case, and again our test case function should start with test in its function name. So we say test add. Now we are going to test the addition function in our myfunc class, and we'll create an instance of the myfunc, and we'll say assert equal. Again we are creating a equal assertion with the function and expected result. As we can see, 1 comma 2 will return as 3, so it should be 3. If there is a problem, you will get this message, it should be 3. So if I run this again, you get OK, and here you can see two dots, meaning two successful test cases. And if I change the expected result to 4, now we'll get, now we can see there's an error over here, and it says, so this is where we get F, meaning fail, and a dot. So one test case has been passed and one has been failed, that's why F. And here you can see the what is failed test add. So this function has been failed, so the error is shown here. Assertion has been raised because assertion error 3 is not equal to 4, and it says our comment it should be 3, and you get failed, and you can get the failures number. So actually you will be getting failures right after there is an raise method has been raised or assertion, but we can come through this in several ways that we'll be showing it later. And we'll also try to check if it returns -1 when we pass in a string to the add function. So this is the thing, and we'll just make it back to 3. And if I run this, now we can see two test cases have been passed and OK. Even though I have tried to test two times, we get only two tests has been passed. The reason is each function is considered as a test, not each assertion. So the passing string of function return -1. So we have passed, we have two dots, and we get okay. So, and sometimes we wanna raise the error, but if I, as we just saw, if I open the myfun class again, here instead of return one, I'll raise an error. So if I try to execute the program again, now we'll get error. We get error is 0, and this cannot be a string. Oh, sorry, error is 1. Yeah, we have one error, and we have E meaning error because there is no failed test case. Instead, there is an error has been raised, which is a raise type error. This cannot be string because we raised an error over here. Sometimes you want some test cases to skip in certain cases, or at least for checking in shortcuts. So for this reason, instead of taking out the whole test case from the module, you can use a decorator called Unittest.skip, which can be used like this. So we'll say unittest.skip and can give it a name which will be printing it if it is skipping, and we can create a skipping class, and also this is also a test case, so we need to append it with the text in the beginning, and we'll say self.fail. This shouldn't happen. So self.fail is a function which will force the test case to fail. It doesn't matter what the argument is expecting or not, it will just fail the current test case when the fail has been executed. So this can be used in several applications. If let's say you are upgrading your API or upgrading your application, and now it is returning a different JSON object or different result in the output, and if you want to check if that is the case, you want to fail the test case instead of showing you error or it simply just passing out. So you can use self.fail. So when this the function has been tested, this test case is executing, self.fail will happen. So if I just take out this uh, decorator, now we can see there is an error. 3 tests has been run, and this should not happen because we have forcefully failed the test case. But if I use the skip decorator over let's say any test case, it will just skip through the test case, and you can say okay, and there is a dot and yes meaning skip, and you will also get a variable called skipped equals 1, which is a tuple containing so many informations. In next decorators, we'll also get failed numbers and failed expected failures and all these things. So our next function is again this is a flavor of skipping a test case, but with a logic. So this decorator is called skip unless, so which is called the unit test dot skip unless, and this takes in true or false, any boolean value. So here we can use any logical expressions. So that is the reason we have imported the platform module in here. So we want to check whether the test case is running on Python version 3 or Python version 2, and we want to force the user to use the Python version 3. If not, we'll print something or we'll raise an error or we'll fail the test case. So we can do that by and just for now we'll say okay, we don't want to pass, we want to fail the test case, self dot fail, and the argument will be um, python 3 is needed. So this will print python 3 is needed if our python version is below 2, and I think there is a small logical error. I think there should be 2, and we'll just print it. Yeah, there is a failure because python 3 is needed because I'm running on python 3, and we are saying skip unless the python is 3, and Of course I'm using Python 3, so we are executing the error, so we want to use 2. So if the user is Python using Python 2, then this will run the function, because skip unless the Python version is 2, else it will just this whole function will be skipped. So if I run this now see skipped equals 2, because this function has to be run, but the logical expression returned false, because we are not using 2. So we are skipping this whole test case. So we'll just move to the next test case, which is expected failure. So expected failure, again we'll use it with a decorator. We'll say unit test dot expected failure. Then again we just wanna declare our function, naming it the test case. We wanna test the square function, but we are expecting the output as cube. That's why I said square with cube. So we'll just create a instance of the test case, I mean the my function method, and we'll say assert equal. So here we can see test square we are passing in 2, and we are expecting 6, which is the cube of the 2, but this is gonna fail. But if you remember, when we expect when we change the number over here, the whole test case has been halted, and we say the yeah, there is an error in the expectation, because 1 plus 2 is not 4, which is 3. We create an assertion, but here we are assertion, but here we are creating assertion for 2, which is square of 2 is 6, which is not, and we are expecting, as we use the expected failure decorator over here, our function will not return fail. Instead our test case is passed, because we are expecting a failure over here. That's what the expected failure decorator does. So if I run this here, now you can see skipped 2 and expected failure is 1. Ran 5 tests, we have not got any error. We got okay, meaning every test case has been passed. And here you can see and passed test case and a skip, and there is a dot, there is an X, which is expected failure. It will be a capital E when there is an error, and F when it is a fail. And there is a yes, again there is a skip, because we use the skip unless method over here. Now there is the last testing method, which is subtests. A single test case having multiple test cases. So let's say if you have seen HackerRank and other of coding challenges, you might have seen the test cases checking, let's say a simple question is print all even numbers from the input n. So we'll use modulus of 2. So here we'll be using for loop when we are printing out all the even numbers. So how do they test? They can just create so many functions for n inputs. So here is where we can use subtest method, so which is goes by like this. So we'll say test sub, which is sub function, and we'll just create a for loop until 6. So we want to print all the even numbers in between 0 to 6. And now we can say with self.subtest of 6, meaning we want to test 6 subtests. So that is it. So if you have range of n, then you can just change the 6 to n, which can be useful, but I'm just gonna stick with the 6. And we're gonna say self.assert, and our even expression, which is I modulus of 2, is 0 or not. So if I run this, there will be 1 and 3 and 5. These three things should raise error, because these will return an number which is not 0. But if you see here, we have again got errors over here. Assertion error, 1 is not equal to 0, and we have run 6 tests. As you can see, we have only 2 tests that can run, and 2 has been skipped, and the third is expected failure. So we have run 3 tests, and there is another 3 tests has been run, because we are getting ran 6 tests, but only 3 tests has been run. Another 2 test cases has been skipped. But how the another 3, which is the test subcase subtests, which are 2 and 4 and 2 and 4. which are the subtests which has been ran in the assert equal function. So this has been added, and also you get the output as failures has been 3. So normally when there is a failure, whole system will be halt, you'll get F as the tag, but here you can see there are 3 failures because that's what we want, because those are subtests, not the main test cases, and there is 2 skip that you can see, skip unless and the skip, and expected failure, which is this one. And of course you can make so much complex test cases using other test case functions from the Unittest library that you can get it from the Unittest documentation. If you scroll down quite a long go down, you get, yeah, from here you can here to use all the decorators and methods. And here I didn't cover about the skip if and skip test things over here, but these method names are self-explanatory, so many functions will be here over here. You can use it, and also you can use regex to expect some patterns as a return, or expect either your pattern is correct or wrong with the test cases using assert. If you go down over here you can see, yeah, assert raises regex. Using this function you can see, if you haven't seen my latest regex video, it will be around top corners, around left or right, somewhere around here. You can click it and watch those things. And if you are using modern IDEs, like as I use Visual Studio or PyCharm, you can also use test cases, automated test cases. Like you can just set up that test cases in Visual Studio itself. You say you open the command palette, and let's say Python discover test, it will automatically scan and it will tell you what are the test files are there. And also now and get any test, I'll configure these things, and I'll create another separate video for PyCharm and Visual Studio how to set up test cases for your projects as default in your settings. And with that being said, I'll see you in the next video. Take care. Bye.